Before we get into our math lesson, I want you to think about this picture. What do you see going on in this picture? I'll pause for a second or two while you're thinking about that. Short kid in the front row. What do you think's going on here? Yes, exactly. These people are spies. Now we're going to connect a spy to some math things. But before we do that, let's think about some stuff that spies do. Usually they go to other countries and their job is to collect information. Often they have to collect this information in secret. So they follow people around, they tap phones, they try to get a hold of emails, sometimes they're taking documents. They have to be very careful though, because there are severe penalties if they get caught. So one way that spies keep themselves safe is to use the art of disguise. And in today's lessons, we're going to think about that concept of spies and how they use disguise. We are going to use something today called an analogy to help us make a comparison in mathematics. We started this lesson by talking about a spy and what a spy has to do, and that one of the ways spies keep them safe is to use a disguise. So my analogy that I want to create is a spy is to a disguise as a fraction is to a decimal. So in other words, a fraction can become a decimal. It's like it can wear a disguise. Let me show you how to do that. So I have two fractions in front of me. I have 5/8 and 2/3. What I'm going to do then is first do my house of division. I'm going to draw my house of division. 5 goes in the box, 8 goes outside of the box. Oop. I must draw that off the screen. Let me just put that in there this way. Okay, so obviously 5 is smaller than 8, so I'm going to add a 0 and a decimal. I'm going to put my decimal in the top so that I don't forget it. This is the place that I'm working at. Alright, 8 goes into 5 6 times, because 6 times 8 is 48. So I write my 48. I draw my subtraction bar. I need to borrow. 10 minus 8 is 2. 2 is too small, so I'm going to tack on a 0 to make it bigger. And now I think of the fact 8 times what number gets me close to 20, and that is times 2. 8 times 2 is, anyone? 16 is correct. Again, you draw your subtraction line, have to borrow. 10 minus 6 is 4. 4 is too small, so we're going to make it bigger by adding a 0. 8 goes into 40. 8 times 5 is, correct, 40. So there, I have just turned that fraction into a decimal. So 5/8 is the same as 0.625. Tenths, hundredths, thousandths. We'd say 625 thousandths. Alright, let's do this next one. So I want to draw my house of division, and we're going to put the 2 in the box, 3 outside of the box. 2 is obviously smaller than 3, so we add our decimal point and a 0. Put your decimal point on top of your division box. 3 times what number gets me close to 20? It's 6. I have 18. So I add my 18, I draw my line, I borrow. 10 take away 8 is 2. We're going to have to make it bigger because 2 is obviously smaller than 3. And guess what? I see a pattern going here. It's going to be 6. And every time I subtract, it's going to be 2. And this is what we call a repeating decimal. It never ends. So writing that fraction as a decimal, I have 0.6. And I draw the repetend side above the 6 to show that it goes and on forever and ever. Now my analogy here was a spy is to a disguise as a fraction is to a decimal. So the spy wears a disguise not to get caught, and we can also turn any fraction we want into a decimal.